هشام مختار عادل in a reservoir engineer with about 13 years experience in reservoir management simulation and characterization. So as mentioned in the introduction, throughout two sessions in this webinar series, me and my colleague Mohammed Sirsi will go through in details with the overview of artificial intelligence and machine learning, the an intensive overview of Python functionalities, Python terminology, Python libraries and packages, and how to develop a neural network model using Python, and also the different types of machine learning techniques and much more with software application and coding from A to Z with different applications. So starting directly for this webinar with an intensive overview for almost 20 minutes. After that, Muhammad will go through with a very detailed example application with how to code and write entities using Python. Starting with the agenda of this webinar, starting with the introduction of artificial intelligence, the differences between AI, artificial intelligence, and machine learning, data mining and analytics, the machine learning paradigms and types. What is then the we will highlight very quickly what is Python libraries and packages. Next is to highlight an overview of the artificial neural networks, and the biological neurons, and how to run and how to make and the procedure of neural network model, and finally example applications. So in very basic overview for the AI, artificial intelligence, which is a branch of computer science which is concerned with the developing intelligent machines to try to mimic or simulate the human-like behaviors, to solve the nonlinear problems and understand from the input data to get predictions and get the results with accuracy and efficiency. So this is actually applied by using different algorithms and statistical models to learn from the input data. So we have many applications, actually unlimited applications of AI in different disciplines, including manufacturing, engineering, medicine, aerospace, and so on. So AI is, as mentioned, the utilization of data science and engineering to creating intelligent system to solve complex and non-linear problems. So in more details, we have common techniques and tools for AI, like the artificial neural networks, fuzzy logic, genetic algorithms, expert system, supported vector machines, and so on. We will highlight some of these tools in this session as an practical applications of some of AI techniques. So, as a historical development of artificial intelligence, back to 1956, this is the beginning of artificial intelligence and applications of computer science to create intelligent system or intelligent machines. In 1997, this is the machine learning beginning, which is a subset of AI to learn machines to understand and get lessons from the input data to make decisions or predictions. Next, which is the type of machine learning, which is the deep learning. It's used to make decisions and understanding the complexity and non-linearity in data by developing neural networks on different hidden layers. And most recently, the generative AI like ChatGPT and so on. This is by to create new written or visual contents based on the input prompts or the existing data. Now what is the data mining or data analytics? This is simply to uh, techniques to understand or to extract insights or to identify the hidden patterns in your data through different techniques as mentioned, like the statistical models, machine learning. So by data mining analytics, you can make informed decisions. So, because in oil and gas industry, especially the subsurface data, we have different types of data like production data, drilling, even drilling data, real-time data from logging or measurement while drilling, artificial lift data, and so on, even core and BVT data. So all of this data we can get and hidden patterns or hidden insights and decisions based on this understanding of this data. So data mining, including the different techniques for data visualization and the big data processing, and also one of the common techniques for this is the for metaphysical modeling like the dimensionality reduction techniques like principal component analysis and so on. So data mining, this is an example of data mining techniques, as you can see, or dimensionality reduction techniques. For example, the principal component analysis, self-organized maps, or linear discriminant analysis. So as you can see, we have and scatter plot between different physical parameters and three common principal components. So the objective of this technique is to try to minimize the size of big database and get the more insights and the relationships between the data or different parameters. So for this example, we have three principal components. For this principal component one, it seems we have a linear relationship with the velocity from open hole logs. Second principal component, we have another linear component, linear relationship with gamma ray and so on. So the conclusion is the data also have insights and details as you have never expect. So this is the objective of data mining and analytics. Another example right here, which is the analysis of production data and try to correlate between the production parameters or even the artificial lift data to predict failures and so on. We will highlight an example for this in this data at the end of this session. Another example for the data mining and analytics, this is the identification of electrophases. So electrophases, this is the utilization of petrophysical data and core data to characterize your reservoir based on the minimum amount of data. So in this technique, we have principal component analysis. It seems the first three principal components have almost 90% of the data, which means you can use two or three principal components and ignore or neglecting the other principal components, as you can see, which means you will minimize the amount of data required without losing or missing significant petrophysical signatures. Another technique like the self-organized maps can be used to identify the electrophases or the rock typing from wireline logs or the petrophysical parameters. As you can see, the message right here, it says using three dependent losology logs like gamma ray and neutron logs and density log. We can the gamma ray. This is the basic required log, and the one of the as you can see, so we have one cluster for gamma ray in the two scenarios. The second cluster or group, we have raw bulk or LLD or NFI and LLD or the deep resistivity. That means one of the porosity logs is neutron or density is sufficient to characterize the your petrophysical data without losing significant information. Another technique like the scattering or scatter plot for or clustering analysis, as you can see, we have four different clusters. For this example, it means we have four different rock types or electrophysics groups. So, what are the machine learning types or machine learning paradigms? We have three common types: the supervised learning, which is the learning from labeled data. So we have set of inputs and expected output. This is representing a vector. So the network will learn from the input data and get lessons to to understand and get the physics of your problems and able to predict the results. Examples for supervised learning, like the predicting the permeability data from wireline logs, the drilling optimization like ROB prediction using drilling parameters and so on. Second technique, which is the unsupervised learning, which is discovering the hidden patterns and from your data without any label data. So no specific output is required from this technique, like the data clustering, electrophysics prediction, reservoir rock typing, and so on. Third technique, which is the reinforced learning, which is we have learn to act based on the feedback or reward or on the input data. So this is the three different machine learning paradigms. So in supervised, let's say we have this is the input data. We have to have a supervisor or the input lessons or input data, and the algorithm which is to mimic the lessons in this input data. After processing, you will get the outputs. We have three different groups or categories. The unsupervised learning, on the other hand, we have no supervision or no specific output is expected from the network. So after the using a particular algorithm and after processing, you will get the outputs. But reinforced learning, we have a closed cycle of learning after rewarding and selection of the algorithm. So based on the best action, you will get the network output. Keep in mind, and most recently, we have several global oil and gas companies currently relying significantly on AI and machine learning, including different international companies and super majors, as you can see. And this list actually is growing day after day. So that's why the studying and developing machine learning models and understanding what's behind is very important. Now, starting with an intensive overview for Python and functionalities and the syntax and so on. So Python is like other programming languages. It's developed to work more quickly and integrate systems and make predictions. It's created by Jaido van Rossum in the early 1990s, exactly in 1991. So what's very common for Python? It's object-oriented language. Interpreted, we will highlight what is the difference between compiled language like C or C++ and so on against Python, which is the interpreted language. Mostly it's a free and open source, well documented, and the syntax is very clean and easy to use and easy to learn. So this is the reason why Python is very common and growing day after day with industry applications. So against other language, so it's for example, C or C++ may be faster but hard to use. Java is maybe also fast but slightly hard to use as well, and so on. So this is what's behind the Python. So now, what is the difference between compiling and interpreting? So any or language required to compile or translate the input code or program um, to a language or to code the machine can understand. So we have, for example, Java source code need to be compiled to get bytecode and then execute to get results. On the other hand, Python is directly interpreting the source code using the Python interpreter to get the results, which is most fast, more faster relative to other language. So it doesn't convert the code into machine code. So we have internal interpreter to make this function. So the process is we have code editor. We convert to source code.py, and then Python interpreter will make the function of compiler to convert into bytecode, and using a virtual machine, we can run this code directly. So this is a compilation against interpretation. So, what is the common problem with Python? We have different versions. We have countless Python packages and their dependencies and so on. And also, even we have different versions for the same package. So this is the main challenge, the initial challenge, but the solution was to generate an Python environment or independent Python environment to keep multiple environments isolated from each other. And within each environment, we can use different versions of Python, and we can keep a set of packages separate, and you can easily run. So Python integrated development environment IDEs. So they are platforms to code or compile or and also run or test and even debug the Python code. So it's not like the normal text editors. So they can understand the code and can learn the details for each variable, each function, or even each library in this code. So Python IDEs, they have vast packages and libraries based for file management, and also have features for code reliability, code understanding, and code detection of syntax errors and so on. We have two categories of Python of the editors, which is we have general editors with Python support like Visual Studio, like Vim, Eclipse, and so on. And we have Python specific editors like Spider and PyCharm. So this is an example of the Python IDE or the Visual Studio. So you can use this this ID or in platform to define or to type or to make script of your Python code, understand the elements of this code, and also you can detect the errors or the details for each element of this code. Also, we have another category of Python online Python IDEs. We have most common. We have Jupyter Notebook, so you can write and execute a Python code locally in your web browser. And also we have Google Colab. So Google Colab, it's cloud-based, so you don't need to set up Python to apply Python application. So using a web browser, you can, as you can see, this is the Google Colab. As you can see, you can generate and make or even test the Python codes like the normal IDEs. This is, and also we have Jupyter Notebook, so you can run and make your Python code. So this is the different Python IDs. Now, what is the Anaconda? Anaconda, this is the it's an industry standard and popular Python environment and package manager. So you can use the Anaconda, as you can see, to generate or to manage your IDEs and to select which ID you need to run. As you can see, we have Visual Studio. We have also Data Spell and also we have Spider and so on. All of these are different versions and also Jupyter Notebook. You can manage all of these environments using Anaconda Navigator. So we have to know very important Python terminology. Scripting in Python terminology means it's a file intended to run directly with a particular set of code lines. But module we have, it's a plan to import it on script, a set of modules. Package, it's a collection of related modules to run together to provide specific functionality within Python. But library by definition means it's a set of or bundle of code or reusable piece of code can be run and executed directly within Python. So we have unlimited number of libraries with different functionalities within Python can be used for different applications. So libraries means a collection of modules and predefined or pre-written set of codes can be run and directly. So you don't need to write this piece of code from scratch and can use this library directly. We have very quick growing number of libraries for Python, and one of the commonly used Python library is NumPy or numerical Python. We will highlight how to an example for this in the next few slides. This is an example for different libraries for machine learning, for data processing, visualization libraries like Seaboard, processing like NumPy, Pandas. For machine learning, we have scikit-learn, TensorFlow, Keras, and so on. And this is the commonly and top-rated Python libraries, as you can see, for different applications like numerical and functions, deep learning, Keras, and TensorFlow developed by Google, Matplotlib for data visualization, Pandas, data analysis, and so on. So let's back to this. Let's for example, in this Python IDE or the Visual Studio, So ID will enable you to understand the elements of Python coding and generate the code line by line, and also detect errors within code line separately instead of finalize the entire code and run and execute the code at the end. So this is the that's why Python is interpreted language. Let's say we need to generate a very simple exercise right now to generate or to define or make a histogram plot. So I will import, as you can see, import. You will import this library as NB. So this line, as you can see, we have color coding and color schema. So we have this keyword and this Python library number. As you can see, we have full details. If you stop your mouse in this line, second line, I will import the another library for the plotting matplotlib library dot Python dot plot. So this library matplotlib, this is for generating interactive plots within Python. Pyplot, this is an module with this library. So library in Python means we have predefined or pre-written set of code. Within this library, you can find different modules like py or Python plot. This is a module within the matplotlib library as VLT. So now we just imported two different libraries. Now I will generate a random number generator for this histogram. RG equals the number dot random. This is the as you can see, this is an module for the number library dot default. So this variable, as you can see, we have a random number generator for a seed of 1. So so this line number 3 will initiate a random number generator with seed value of 1. And next I will generate two code lines to build a vector of the normal distributions of a particular mean value and standard deviation. So mu and sigma, this is the equals 2 and 0.5. So mu, this is the mean value and standard deviation for this histogram. And next new variable v equal rg random generation dot normal. As you can see, function of mu and sigma, and as you can see, and this is the so I will generate this one to generate a random number generation for the normal distribution of 10,000 values. So this is the number code lines 4 and 5 will generate a vector of as you can see of 10,000 normal distribution with mean value of 2 and standard deviation of 0.5. Next line I will employ this matplotlib library to generate this histogram dot hist function of the variable v defined before, and in terms we will generate this histogram with number of bins equals 50 and the we have normal distribution function, its density is 2. So the last code line in this very simple example is after the using the matplotlib library to generate a normalized histogram with 50 bins. Next is to show this plot. So blt.show, and now click run. So it's as you can see, we have so this is the importance of IDEs. So you can as you can see, you can define, or you can script your Python code step by step and understand what is the type of variables, like the mu and sigma, the mean value and standard deviation. What is the type of this variable? We have floating value and integer, and also different modules and required data and so on. So in Python, as mentioned, we have different techniques to run and execute a Python code, like the Anaconda IDEs, like Visual Studio. You can even use the online Jupyter code, like this same code. I will run this code, as you can see, using web browser. Even you can use, as you can see, Google Colab to run same code on this cloud-based application for Python. So now back to this to go through with the applications of AI in EMB industry. So we have unlimited applications, the common applications including reservoir characterization and management, well testing, design and interpretation, BVT and equation of state modeling, hydraulic fracturing optimization, oil production data and artificial lift system optimization, reservoirs and simulation, physical modeling, and so on. So this is as well as we survey what are the commonly used AI techniques in oil and gas industry. So as colored in green, machine learning or neural networks is the widely used technique in terms of the published SBE papers and their applications, followed by, as you can see, genetic algorithms, fuzzy logic and hybrid system. That's why we are focusing more and getting more interest for for the artificial neural networks. Also, as per SPE, AI, BA, the AI predictive analytics. This is the common EMB applications for the data mining in the oil and gas industry, um, the production optimization, reservoir simulation, and system prediction and automation. So Python for petroleum engineering, we have different applications like data analytics, visualization, system optimization and automation, failure analysis and prediction, and also we have Python specific petroleum industry specific libraries. We will highlight some of them in next few slides, and we have different machine learning techniques. Will highlight it shortly, like the k-means clustering, non-linear regression, support vector machines, decisions trees, and so on. Also, in most of petroleum industry, standard software packages are developing and are integrating or maybe employing Python for machine learning and for data analytics, and maybe for field development planning, for simulation model, history matching, for metaphysical modeling, like TickLog, for well modeling and system production network optimization, IBM, GAP, and OpenServe, well modeling and optimization, and the transient well modeling and flow assurance like Olga and PipeSim. Also, a reservoir simulation like T-Navigator, and the advanced reservoir simulation from SLB like Intersect and the Petroleum, and also physics modeling like the geolog paradigm. Here are some example of Python libraries specific for oil and gas industries like this one, NXM for BVT modeling, and this one GenBy for 3D geological modeling, as you can see, and this one, for example, ByScal for generating relative mobility and capillary pressure using a small number of code lines. So let's back for to this Google Colab. We have this five lines of code using ByScal library. So if you run this code, so we have so this is the let me check for using this some lines of code you can generate and predict um, the relative mobility and capillary pressure curves based on some inputs. As you can see, this code is used to generate the relative mobility curve using SW versus KRO and KR Another key library like Glacier for well logging and visualizations, REST4 and deep field packages for reservoir simulation, as you can see, can be run in parallel with other soft reservoir simulators. This one for also for reservoir simulation. BSA by this is the for production system analysis and generating the well models, IBR and vertical lift performance models. And this library for sand management, as you can see, this is the features, and using this code you can predict the expected sand rate, as you can see, based on some inputs like the maximum velocity, gas liquid ratio, acoustic response, and so on. So now in a very few slides, I will highlight an overview of artificial neural network, and next we will have an practical applications with my colleague Mohammed Sirs. So the concept and the principle of ANN, the artificial neural networks, is coming from the behavior of the biological neuron. So the human body or human brain can apply, you can perform complex and non-linear processes or tasks like brainstorming, the language understanding, and so on. So what we need to perform right here is to try to mimic the behavior of this biological neuron to analyze and make predictions from the data. So the human brain is actually highly complex, nonlinear, and parallel processing unit with the very huge number of the connections between a neuron or nerve cells. So we have the three basic elements for a biological neuron or nerve cells. We have the dendrite, which is sensor to get the signals from nucleus. Nucleus, it's based on the incoming signal from they can make decisions. Ax Axon, it's carries the produced decision to the neighbor neuron, as you can see. So we have dendrite right here, and this is the soma or cell body for the nervous cell, and this is the axon terminal, and the output is based on synapses. This is transmit signals to at the axon to the nucleus of the next neuron. So the basic principle for an artificial neural network model, it's simply the output of a neuron. It's the function of the weighted summation of inputs plus bytestone. So let's say we have a set of inputs to a neural network from x1 to xm, and we have weighting factors or weighting parameter wi1 to wim. So all of this, the weighted summation of these inputs will apply summation at this part plus the bias term. So the output of the network yi, it's the activation function of the weighted summation of input, as you can see, plus this theta I or the bias term. So what are the activation functions? It's a function to generate the network output. We have different forms of the activation functions, as you can see, like linear activation function, sigmoid, tangent activation function, so on. And the process is to define a particular input layer based on the available number of inputs, assign the number of hidden layers, and define the network output. So in a simple neural network, the process is to generate summation of the inputs times the weighting parameters plus by term activate or use or perform the activation to get the output. But deep neural network, we have multiple hidden layers. As you can see, this is to solve or simulate the complex and the non-linear problems. So we have inputs, weights. So this spice term will be added right here at this the summation of weighted inputs, and then apply the activation function to the to get the network out. So the designing a neural network model, you have to define the network structure in terms of feed forward or feedback neural network. Based on this type, we have different structures. Initialize weights and biases for the bias terms for the network, and then assign the training algorithm. We have different training algorithms like the back propagation, the conjugate gradient, Levenberg Marquardt, and so on. And next step is to propagate the error and get the network output and check for the convergence error. And so you can evaluate the accuracy and the prediction capability of this network. So you have to adjust weights and biases to fine-tune this network and try to improve the network accuracy and the prediction capabilities. So the major steps after definition of objectives and set of inputs and outputs, data preparation like uh, data normalization, transformation, outliers, and so on. Use the dimensionality reduction techniques. Build the model to assign the structure of model, number of hidden layers, number of inputs, and so on. Data splitting into three different categories for training, for validation, and for testing. This is the model deployment to assign the training algorithm and the stopping criteria, and finally evaluation of your model based on the convergence error. So in Python development of a neural network model, you have to import the libraries, the required libraries, or the corresponding libraries. NumPy, for example, TensorFlow, Keras for the deep neural networks, preparing the data splitting the data into different categories for training, validation, and testing. Build the network in terms of hidden layers, activation function, and so on. Compile model training of the model or the stopping criteria, number of training cycles or number of iterations, and finally evaluation of this model of this network. So we have different techniques for data pre-processing, including the normalization. I will not go through in details for this. And here, very important aspect regarding neural network for the generalization and regularization. So generalization means the to avoid the overfitting or underfitting of the network. Um, so in the underfitting, all the validation and training error are high, but which means the network is not capable of to predict the results very well. Over vetting, we have very high degree of training, which means the validation error is high while the training error is low. Basically, the training data are used to teach the network from the input lessons, while validation is to validate the model without any adaptation of the network, like the weights and biases, while testing data set is to evaluate the performance of the network. So the optimum stopping criteria, as you can see, as long as we have a reduction in the training error and also validation error, so the network is performing well. But once the validation error starts to increase, like at this point, and we have continuous reduction in the training error. So this is the optimum point, optimum time to stop training at this point. So this is the early stopping criteria for a neural network. And in this example, we have developed a neural network for vulnerability prediction. So we have, after data integration and data analysis, so data splitting into three different sets, as you can see: training, validation, testing. So apply training and monitor the validation error. If we have satisfied validation error, so we can go to the testing to evaluate the performance of this network. So now this is the end of my topic. Now my colleague Muhammad Sirsi will start with an example application for the analysis of production data. Muhammad.
And we can see my screen right now.
Yes, go ahead, Muhammad.
Okay. As the engineer Hisham has put a solid foundation for all of you today about machine learning and about Python, and give a solid introduction for Python and machine learning usage in petroleum industry. Now I will take you through an example to predict the oil production rate from the production data. My name is Mohammed Sirsi, and I am a senior reservoir engineer, and I have experience like 10 years of experience, and I hold a master degree in machine learning application in petroleum industry as well. So today, this is our practical application we are going through to predict the oil production rate. What this project aim for, we aim to predict the production rate using machine learning techniques. We will use the linear regression model, and we will give an introduction to it, how it works, and we will use some advanced model like a random forest. So any project workflow, we need to define some steps and to follow to apply any data science project or any machine learning project. We have to identify our workflow. So first of all, we need to identify the problem. So in our case, what is the problem we have? The problem we have some production data, and from this production data, like the rate and different rate, like oil rate and water rate and gas rate, shock size, wellhead pressure, wellhead temperature, downhole pressure, stuff like this. We need to identify the production rate without needing the sensor or stuff like this, or without using techniques like normal techniques like decline curve analysis. We need to use machine learning to evaluate the production rate. So we have defined the problem we have. So we have defined the problem. So second thing we need to do, we need to gather the data. So we need to collect the data from relative sources. In our case, we will have the data coming from sensor or from well test, and we gathered it in Excel sheet. And we will have a look on this and on the data in the next slide. Then we need to clean and prepare the data for work, because any model you will build need to have the data cleaned and well prepared. Because if you input rubbish into the model, the output will be rubbish. So the data must be correctly prepared and cleaned. So cleaning processing can be done in Excel or can be done in Python. You can use it to fill the missing data or exclude the missing data. You can do it by Python or using Excel, whatever you want. But the data we have here in our example, it's already cleaned and it's ready for illustrating the example directly. So after we have the data, we need to find insight and explore the data. So we need to have to look in pattern in the data to see the relationship between the data and each other, and which future we are going to select and which futures we are going to neglect in building our model. So we don't take all the future to build our model, and we don't neglect all the future. We need to find the relation and the pattern between the futures and each other to find the most optimum futures to build the model. After this, we will split the data and try to build the model with different technique, with linear regression, logistic regression, artificial neural network, whatever you need, whatever the model is designed to, as Engineer Hisham explained before, that you have different types of machine learning, supervised and unsupervised, and unsupervised it's classification or regression problem. So depending on your problem type, you will choose a specific machine learning algorithm and try to apply it on the model. Then after this, you need to evaluate this model. You need to evaluate this model by accuracy metrics like the R score or the mean absolute error, or if it's a time series case, like in our case, we don't need this. We can use date versus time chart to see the results. After this, you can share your finding by employing dashboards for your results, or employing this model into an application, and use this application to predict future results based on the data you have trained the model on it. So the steps we are going to follow is to data preparation, then model training and evaluation, then finally visualization the results, then we will see the conclusion. So we will explore the data we have. We have a CSV file. Let me show it to you. This CSV file contains in the first column the date and some columns related to the production data, like the production hour, injected volume, wellhead pressure, wellhead temperature, choke size, and the rate, and some of them are zeros and some have values. And this is the CSV file. So where is this data came from? This data is for well F12 from Field. Field is located in North Sea, and its data it's open source. You can download it very easily from Equinor website, and you can have access to this data very easily. So after this, let's go to the code and see. I will use Visual Studio Code to implement the code, and I'm using Jupyter Notebook extension or Python Notebook extension. So I'm not using a Py file. I'm using a notebook file. So you can open Notebook via Google Colab or via Jupyter Notebook or via VS Code, but you need to download the extension to open the notebooks. First of all, we need to import the libraries we are going to use. So I will import NumPy as NP, so I can later use NP instead of typing all NumPy. I can use NP only to import the library. Then I can import pandas to make the data frame, and matplotlib and seaborn and plotly express for data visualization. After this, so we need to run this line of code. So he asking us for selecting the Python environment we are going to use. I will use the base Python environment 3.11. He's connecting to the kernel, and done. The first line of code is done. In the notebook, you can run line by line, but if you run this line before this, the second line before this line, it will give an error, like example, because I didn't define the data frame yet. So I need to run this line first, and then this line. So it should be done sequentially, line by line. You don't need to execute the whole code at once, but you done it line by line. Okay, is this clear? So what I have done here, I have loaded the vol field, this CSV file here. I have loaded it into a data frame using pandas, using the method read CSV. So the read CSV takes this file that I have mapped it to it, and make the index column equal 0. What does it mean? It will take the date column and it will consider it as index. So then I want to visualize that my data frame is fully loaded in Python. So I use data frame.head, and I open and close the brackets, and that's it. And shift enter to run the code. And this is a sample of my data set. So if I want first four rows of my data set, I can type here 4, and it will give me the first four rows, and I can type 5, and it will give me the first 5 rows of my data set. So later I want to get the names of the columns of my data set I have. So I can use this method called columns, data frame dot columns, and I can run it, and it will give me all the columns names that I have in my data frame or in my Excel sheet table. So after this, we need to select the input and output parameters we are going to use. So in our case, we know the outputs that we are going to use. It is the bore oil volume. So we want to predict the rate. So the output column is going to be the bore oil volume. This one is going to be the output. So later I need to select the input that I am going to predict the output from it. So I should select any input? No, I should make a person correlation. There is several ways to select the inputs, but investigating with person correlation is can be easily achieved by using this line of code only. So I am using seaborn library to do a heat map plot for the data frame correlation. So if I run this code, I need to run this first. And if I run this code, you will see that it make a correlation between every input and each other, between all the data set and each other. But you can see this graph, it's not interactive graph. And this is the color legend here. And this is the relation between each input and itself. So you can see it here, it's all the diagonal is one. But this chart is not interactive chart. If you want to use interactive plot, you can use Blockly library, and you will do the same. You will define a correlation matrix as a data frame dot correlation. Then you will define the figure, and you will use Blockly express dot mshow, and you will pass the correlation matrix we have here, and you will define the x named and the x-axis column named and the y-axis column named, and then you will say fig.show. You can run this code. You can see here that this chart is interactive. When you stop on any box, you can see between which correlation. This is between the bore water injected volume and itself, and the correlation is 1. And you can see if you stop on any box, you can see the correlation between which x and y and the value of the correlation. So what I'm going to need here, I want to know the correlation between the input and the output. I don't want the relation between all the inputs and each other. I want only between the input and the output. So I will define a variable called a correlation series, and I will define a data frame dot correlation, but I will get the relation between the output column only, which is the oil rate, and I will make him sort the value in ascending order, in descending order. So ascending, it's a false. And I will make a chart for this to visualize the result. Let's see what it looks like. So this is how it looks like, the chart. I can show you the table of this data. So this is the correlation between each input and the output, which is the oil rate. We can see it here. The correlation between the gas volume and the oil rate is very high. It's almost nearly 1. And you can see it is ordered in descending order from high to low. So what I need to take in as an input for my model, I want to consider any input that it's between 0.2 and -2 and have correlation higher than 0.2 or -0.2 with the output. So we can write this in the code like this. Let me show it you. We can write it as the following. I want the input columns to be the correlation data frame, this one that I have created here as or this table. When the absolute will take the apps value for each this. So I want the minus, the correlation with the negative, and the correlation with the plus. So this is a negative proportional, and this is a positive proportional. So I need both. So it will exclude only this 3 inputs on the stream inject hours and average analyst pressure and average shock size pressure in percentage. It will exclude these 3 inputs only, and it will generate the input columns as we can see. If we want to show the input columns only as well, we can type input columns, and we can see the input columns will be the average downhole temperature, the average downhole pressure, and the average lead pipe tubing, and wellhead pressure and shock size, and wellbore injected volume, and wellhead temperature and water volume. And he neglected these 3 parameters that is less than 0.2. So after this, after we have identified the input that we want and the output is the production rate, we need to identify each table into different table. So like so, we want to create a data frame for the inputs and the outputs. If we can see that we have a data set consists of 3,291 row of data, and we have chosen 9 variables into our data set. We want to classify this as our X or as our inputs, and we will give it the letter X, and we will define our target, which is the oil rate, as Y, or it represents the output that we have. So we can do this simply by applying this code. We want the data frame that we have introduced earlier to be X as input columns and Y as output columns. So this will be the inputs and this will be the outputs. We can run this code and we can show the X. So the X will be the 9 parameters we have chosen, this column, and the index is the date. And the Y will be one column that contains the oil rate. We can make sure that is that's the same shape by using X shape and Y shape. And we can see that the X shape is 3,291 multiplied by 9, and the shape of Y is 3,291. So we can check this here. So that's right. The X dimension is 3,291 multiplied by 9, which 9 variable, and the output is 3,291, and not multiplied by anything, it's one column. So after this, we need to split the data into training and testing dataset. How we will do this? What we are going to do is we want to split the X and Y into a training and testing dataset. It is very different when you use time series problem to split the data, different than ordinary regression problem. When you split the data in regression problem, ordinary regression problem, not a time series, you don't have a sequence of data. You don't have dates. So you can split the data randomly. But in our case, we don't need to split the data randomly. We need the first 3,000 point to be splitted, and the remaining 291 point to be splitted differently as X test. So we will create 4 other data frame. It's called X train and Y train and X test and Y test. By using this line of code, very simple. We can specify the training length is 3,000 days, which is here. We will split the data from here, and all this will be X train, and Y that we have identified before will be Y train, and the rest of the data will be X test and Y test. So we need to define X train and Y train, and we need to locate from 0 till train length that we have identified here, 3,000, and Y will be identified from 0 till train length. And the same goes for X test and Y test, but we switch the semicolon location. And we can run this code, and we can verify the shape of X train and X test. We'll find that X train 3,000 by 9, and X test is 291 by 9, which is true. This is X train 3,000 by 9 variable, and the X test is 200 is the 3,291 minus 300 will be 291, which is the X test. So we have splitted the data into a training and testing sets successfully. So let's try to build the machine learning model or our multiple linear regression model. It's very simple. We can build it very easy. We don't need to use a scalar here because we can use multiple linear regression without using a scalar. We don't need to run this code. So we can apply this code from this line. So from scikit-learn, we will import the linear model, and from it, we are going to import the linear regression. Then we put our linear regression model into a container which is called linear model. Then we will use it to fit the X train and Y train. Let's run this code and let's run. Voila, we have done our first machine learning model. We have fit the training data and Y data. We give the model, the X train, we give the model this data. We give them X train and Y train, and we told the model, fit this data together and produce for us a multiple linear regression model to estimate in the future when I give you X test or unknown data without Y test, and you give me the prediction. So I will save the prediction in Y predicted train, and I will use the models that I have fitted into X train and Y train, and I will use X train, which is this data, to predict the YP train, Y predicted train. And let's see. So what we have done here, we can plot this into a chart. So what we have done here, we have plotted the actual data, the date was versus production, the date on the x-axis, and the production or the oil rate on the y-axis, and the actual data is by marker orange, and the predicted data that we used the linear regression model to predict is marked by red line. So let's continue. We can use y predict model on the x test. So we will predict on this data to predict yp test. Let's see. So what we have done here, we have predicted the other part of the data that we haven't given to the model to fit on it, and the model have drawn for us the predicted values, which is presented by the black line, and the actual values by green markers. And this is the line where we have taken the train test split ratio, which represent 3000 time step from the start. So let's explain how the linear regression, multiple linear regression model works. In this example, we have used the multiple linear regression model to predict our data. Simply, the multiple linear regression model is considered a simple neural network. As Engineer Hisham explained in details how the artificial neural network works. So it consists from input layer and output layer, and between them hidden layer. But in multiple linear regression, we don't have hidden layer. We just have input layer and output layer, and we have the equation of linear equation. And in our case, we want to predict the oil rate, which is y hat here. And we have several inputs like the wellhead pressure, wellhead temperature, or whatever inputs we have. We have 9 inputs, and we need to specify the weights of each one and the price to get the results. We can do this by machine learning by this few lines of code we have illustrated in our example to get the outputs, which is production rate. So in our exam, in the next slide, we are going to explore the difference between the results of multiple linear regression and between more advanced model, which is the random forest regression model. How random forest regression models actually work? Random forest is consist from different decision trees, which is take the input from the first tree, the inputs, and take the result from the first tree and second trees and third trees, and average them by use bootstrapping and put average for all the result, and then get you the final results. This is a simple idea of how random forest model work. So how we apply this by using the code, we can apply this by import ensemble learning from scikit-learn and from it we can import random forest regressor. In a classification problem, you can use random forest classifier. So, and in random forest regressor, we will put it into a container called RF. Then will use this container to fit our X train and Y train data that we have previously defined. Then we will predict the Y predicted train for the X train data, and we will predict the Y predict test for the X test data. So this is the machine learning code. You have made a machine learning model in just 5 lines of code. You don't need to run to make the random forest code from scratch. You can use scikit-learn library and use the model directly from it, and in just 5 lines of code, you can make your own machine learning model. So let's run this. So finally, we can visualize the results by using this code. I can explain it by using Plotly expresses. This actually make a trace for the history and make a trace for the prediction. Each trace you can define here, and then you can type figure show in the end. And this is what we have. And you can see the difference between the match in our history match data by using random forest, and here by using multiple linear regression. And you can see the difference also in the prediction by using random forest and by using multiple linear regression. So the conclusion is we have successfully demonstrated the use of machine learning to predict the oil production rate using various types of machine learning, the linear regression model, which represent very simple neural network, but it's completely different. And we have explored also the random forest model, and it enhanced and improved the accuracy of the prediction very much. So this is a very simple example on how to use the machine learning application on the production data. And if anyone has any question, I will handle the session to PEA to handle the rest of the session. Thank you very much.